we are answering question B from section B. So the question is saying, in the laboratory an experiment was done to investigate the effect of temperature on the rate of reactions. So the rate of reaction was given by the expression, this one here. So here we are focusing on the effect of temperature. What is the effect of temperature on the rate of the reaction? So the kinetic data obtained in the experiment is given by the following linear equation. So always what should come in your mind is that linear equation is always expressed in the form of y being equal to divided multiplied by x multiplied by the y-intercept. This is the way it's supposed to be expressed, right? So we have A, B, and C. So where A, B, and C were obtained by plotting a graph. Alright, so question A is saying, write the Arrhenius equation, 2 marks. So Arrhenius equation is given by the rate constant, which is equal to the value of A multiplied by the exponential, then activation energy, which is negative activation energy, divided by RT. So R is the gas constant. In this case, it is approximately 8.314, and it is measured in joules per mole per Kelvin. Okay, so some they write it in this way, just okay. So that is mole, then that is Kelvin. So okay. So this value they are not going to give you, or they can give you, so just need to know it. So for the first part we have answered that one, so that is how you're supposed to write that one. Now for question B, it is saying, what is the effect of increasing the temperature on the rate delete. So let me just write the Arrhenius equation. So this is our equation that we have. So whenever you have exponential flip things, right? That is one thing that you need to know. So if we have k, which is directly proportional to the exponential x, then divided by t. This means that immediately you have an exponential here, meaning to say that things are going to change here. From the actual things, if you have k, which is inversely proportional to the temperature, meaning to say if you increase the temperature, if the temperature is increased, what is going to happen to the value of k? So the rate constant is going to decrease, but immediately you have the exponential, meaning to say that things are going to be opposite. So if you increase the temperature here, even the rate constant here is going to increase. So increase in temperature is directly proportional to the increase in temperature. Increase in temperature increases the rate constant. Okay, the rate constant k in this case here. So that is our answer for Roman numeral number 1. So now for Roman numeral number 2 is saying on the rate of the reaction. So when the value of k is increased, you are going to find that even the rate of the reaction is going to increase. So even the rate of the reaction is going to increase. Rate of the reaction will also increase. Okay, so that is one thing that you need to know here. So meaning to say, if the temperature is increased, okay, so if the temperature is increased, what is going to happen to the value of the rate constant? It is also going to do what? It is also going to increase. Then let's say if the rate constant is increased, what is going to happen to the rate of the reaction? The rate of the reaction is also going to do what? Is also going to increase. So that is one thing that you need to know about this equation. Then as for question C, it is saying draw the labeled sketch diagram to show A, B, and C as indicated in the above linear equation. So let me just write that linear equation and then compare with what we have. Question was saying this one is written in the linear equation, meaning to say that this is written in the linear equation in this form. So let's identify our y. Let's also identify our gradient and the value of x as well as the y-intercept. So y here is equal to negative ln t. Then the gradient that we have here is this value here, which is negative 4.4598. Then multiplied by 10 to the power positive 3. That is the gradient. The value of x is 1 over t. Then the y-intercept, which is c, is 11.32. So this is what we have. Now let's see what we have here. So this is the position of A, the position of B, and the position of C. So meaning to say that this is A, this is B, and this is C. I think that is what we have, isn't it? Yes. So meaning to say that if I were to indicate what I have here, this one can be also equal to A, and this one can be also equal to B. So the gradient is equal to B. And then x, it is this one here. Then the c-intercept, let me say the y-intercept is this one here. So this is what we have. Now the gradient is negative. So if I were to draw the slope here, we are plotting the graph here. So when you are plotting the graph, you need to plot y against x, isn't it? So this is my xy plane. It's just a rough sketch of xy plane. So what am I going to have in the x, and what am I going to have in y? So in y, what do we have here? We have that, which is negative ln t. Then on x, what do we have here? We have 1 over t. So I'm just getting from here. So y is ln t, so I'm going to indicate that. Then x is 1 over t. So this is what I have. What is our y-intercept? So y-intercept can be somewhere here because it is positive. So it is going to be positive 11.32. Okay, that is our y-intercept. Now what about the value of x here? The value of x is 0, so it's more like we have 0.11.32. That is what we have. Okay, now that the gradient is negative, so meaning the graph has to go like that. It has to be straight. But since I'm not perfect, and I'm just going to draw a line which is just going to cross here. Actually, it's not going to be straight, but I'm just going to try to draw it straight. So this is what we have. So that is how it's supposed to look like. Okay, so let's identify B and ABC, because the question was asking us to identify what these are. So this is where we are going to have our C, the value of C. That's a C-intercept, or the y-intercept, I can say. Then this is where we are going to have B. Then this is where we are going to have A. Because why are we saying this is where we are going to have A? This is the x-axis, isn't it? And in the x-axis we have 1 over 10. So the value of A is going to be here, because we want to say that in the x-axis we have 1 over 10. So A, then the gradient here is B, then the y-intercept is C. So this is how you're supposed to draw that one. So let's see if we have more questions. Alright, so we have question D. So for question D, it is saying determine the reaction time at 50 degrees Celsius. So always when you have been given the temperature in degrees Celsius, you need to convert it into kelvins. So how do you convert that? So you just need to add to the absolute zero temperature. So the absolute zero temperature is 273 kelvins. Then if I add, what am I going to get here? So I'm going to get 323 kelvins as my temperature. Now the question is asking us to calculate, to determine the time. So we are just going to use the same equation, this one here. Okay, so the temperature we have, now we are finding this T. So let me just rewrite this one. So when I do the computation here, when I multiply, then add, subtract, I'm going to get, so here on this part we have negative ln T, which is going to be equal to negative 2.6. So you can just confirm by multiplying and then add here. We're going to get this one here. So here you can see that we can divide by negative 1, then here negative 1. So we are remaining with ln T, which is equal to positive 2.60, because negative and negative, they are going to cancel each other. So I can introduce the exponential, which is E. So E ln is 1, so I'm going to remain with T. So E ln is 1 or ln E is 1. Then when I punch on the calculator, that is shift, then you place ln, you're going to, this one is going to come, which is exponential E. Then you place 2.6. So what are we going to get? We're going to get 13.5. 13.5 is going to be our value. So we are looking at time, so it's going to be measured in seconds. So that is how we're supposed to answer this one. What about the activation energy? 5 marks. Activation energy, it is just very simple. From the look of things here, since that equation is written in the linear equation, it is written like this, isn't it? Then here we have identified that, okay, so we have identified that this is our y, this is our gradient, 1 over t was the value of x, and then 11.32 was the y-intercept. So it is just very easy. Okay, so if you see clearly here, gradient is equal to the activation energy. Okay, gradient is equal to activation energy. So we can just say, since the gradient there was negative, so we can just say gradient is going to be equal to negative of activation energy divided by R. So where is this one coming from? Let me just show you where it is coming from. So if we have K, which is equal to AE, then we have negative activation energy divided by RT. So immediately I introduce ln to both sides here. What am I going to have? I'm going to have ln K, which is going to be equal to, you know that ln E is 1. So what are we going to have? We are going to have activation energy. Then from there, so we can have activation energy divided by R, then open bracket 1 over T, then here we can say plus ln A. So this is what we are going to have when we work out what we have here. Okay, deriving this equation, they're not going to ask you to derive this equation. I just want to show you what is happening here. So meaning to say that this one here is similar to what we have here. This one, the entire thing here, is the same thing that we have here. So meaning to say this is y, this is the gradient, this is the value of x, and this is the y-intercept that we have. So that is one thing that you need to know. So if we were to, this is the y-intercept, so if we were to compare here, meaning to say that we are saying that gradient is this one here, and the gradient here is also this one here. So M is going to be equal to negative activation energy divided by R. Since they are equal to each other, gradient is equal to gradient. So what is the gradient? From the question, or from this equation here, the gradient is this negative 4.498 multiplied by 10 to the power positive 3. So you need to indicate a negative. So negative 4.498 multiplied by 10 to the power positive 3. Then this one is going to be equal to negative of activation energy. Then the value of R, which is the gas constant we know, it is 8.314. Okay, so I can just multiply. Let me just do this. So meaning to say that this negative here and this negative, they are going to cancel each other. Then just the need of us multiplying this one and this one. So activation energy is going to be got, when I multiply this one multiplied by that, I'm going to get 37,396.372. So since activation energy is measured in joules per mole, but it is usually expressed in kilojoules per mole, so I'm going to divide by 1000 here, since kilo is equal to 1000. So when I divide by 1000 there, my activation energy is going to be 37.4 kilojoules per mole. So this is our final answer for the first question.